Most of the time on KitPlus TV, we introduce our guests with something relevant to the technology they're coming in to discuss. This time it was very easy because they already have the words explaining it all.
So in their words, providing audio production services for outside broadcast events and sports has slowly been moving away from the traditional OB truck scenario as the industry battles with reduced budgets and, more recently, the need to reduce engineers physically being in attendance. This has resulted in new solutions to manage audio productions, remote and at home production.
So today we're chatting with Tom from SSL about their decentralised and distributed remote audio production. Hi Tom, how are you doing? It all sounds very complicated, interesting. Could you sort of sum it up for us?
I think what's happened is there's been a shift from the more traditional remote production to a kind of at home.
Yeah.
And they both have similarities, but there are some stark differences, and perhaps a kind of more encompassing term that gets floated around is decentralised, literally meaning not all in one location. So
not all in
I think,
one place.
not in one place. So it's probably, if you think about the remote scenario, you're typically sending equipment to a venue, to a place where a production is happening, and you're controlling that from a typical large console sat in a broadcast center like is sat behind me, and you're remotely controlling what's going on at a venue. Whereas the at home is kind of the scale flipped the other way around. You're kind of sending a smaller section of the control position to someone's house, often in their garage or kitchen or wherever it might be, but you've kind of sent a small part of the control to someone's home. So, and then different operators for different parts of the show. So the audio, the video, all the different operational positions are distributed and decentralized around sometimes the country, sometimes continents.
So Tom, how has SSL satisfied these new requirements?
So kind of from the ground up, the System T's kind of product range was all built to work on networks. It kind of splits it out into the different components, be it I/O, be it processing engines or control surfaces. And the software that runs on the control surfaces itself is actually a set of applications that all communicate on a network. So kind of built into it was this idea of the kind of remote and things working across networks. I think what's changed is those networks have become less about managed networks and more about kind of even public internet. So we've kind of adapted to how the devices scale, and they can scale across that. So you could send, for instance, if it was a remote type scenario, you'd send a processing engine and some I/O to a venue, and that would be remote control from a console. Or if it's the at-home scenario, the same software that runs on the console, you can also run on a standard computer. So you can run that on a PC. And if you want, you can control it entirely from a touchscreen or from the PC, or you can connect physical hardware, so a fader tile into that PC, and build yourself a control position at home.
Yeah. Now, I reckon we were talking about System T, and you were developing this kind of thing even before we were in COVID, and we were probably at NAB or IBC. The last couple of times we were. System T's been alive for a while. So, what changes have been made to the product? What's been accelerated, if you like, since remote has been so popular?
So definitely. So System T, it's been around for a few years now. And kind of from the beginning, it was always built to connect across networks. One of the things we accelerated was the ability to connect over public internet. So make it really easy to connect over a VPN. And one of the things about networking, and this is across the whole scale, whether it's I/O devices or control devices, is discovery. So discovery is obviously a part of people talking about IP often when we talk about I/O and transport. And so, in fact, discovery over things like VPNs is a little harder, and you might actually not want discovery because you don't want anybody to see these devices. So it's about making it a kind of target and a manual address. So we've adapted it and kind of we basically brought forward changes that were planned anyway to make it much easier to do remote control over VPNs and standard internet connections.
So what about the audio signal between the locations, with the operator obviously needing to hear what's going on? What are the challenges involved in that?
So yeah, as you say, you have to have audio that the operator needs to hear what's happening. And this, particularly with the at-home model, this became public internet. And what you don't want to do is bring all of the audio signals across the public internet that you are then putting out on air to program. That would seem like a kind of dangerous on one hand, and also a very bandwidth heavy and kind of a not particularly good use of that internet connection. So key was leaving the audio signals that are kind of the microphone inputs and anything that's program output or any of those signals, leave them where the processing engine is. That could be at the venue, as I've said, or it might be in your broadcast center that you can't all access. Maybe you're locked out or you can't have all the staff go there. So leave that in the controlled and managed networks. So leave that as Dante, AS67, 2110, at where the processing engine is, and then just bring a monitoring feed over the public internet. And there are many codecs that are useful for doing that. And so rather than reinvent the wheel, it's like, well, just hand off the signal from our console to that codec and bring that across back to the monitoring position. What we've also found is in most cases, you're bringing video back to that position anyway. Most video transport streams that are designed for internet have an audio portion to them. So people have been adding audio to SRT or putting across the audio on NDI and bringing that with their multiview. So they're monitoring the audio, but also the video.
So, that covers kind of the bandwidth, so to speak, and you can use all these efficient codecs and everything to get it over. But you're talking, on occasions, you might be talking long distances here. How's latency being affected? How are you dealing with the latency?
Well, we have to consider latency. That's part of it there. So I guess a key part is, as we've said, the kind of production audio is all going on at the venue or back in the broadcast center, not at home. And so if there are any IFBs or anything like in-ears, that's all happening quickly. So there's no latency in that respect because the processing engine is where the talent is. But there is latency back to the control position. There's both an audio latency and a control latency involved. So when you move a fader, the audio in the engine has to adapt and move that, and then you hear it back when that happens. So we've kind of done some tests to do that, like as we're kind of planning it out. We did tests between New York and LA. We did some tests between Oxford, where SSL HQ is, and New York. And in both those, kind of the round trip ping time latency was about 70 milliseconds. And that was actually barely perceptible once you're using it. That was well within kind of the capabilities of someone mixing audio. Once you push that up to above 100 milliseconds, it starts to get a little bit more obvious. And I think some of the work that's come out of that is it depends on the program and the kind of production types you're doing. So things that require fairly slow mixing, you've kind of set a level and go for it, that would be allowed, like a larger latency would cope with that, but quicker things are going to require a short latency time. And that's kind of part there. But then there are other tools. So things like dialogue auto mix that you've got on the console. So this helps by automatically mixing microphones as people speak around a table, but those tools kind of help cover any of the latency issues you might observe.
So to finish up and maybe summarize, if someone out there watching this is thinking of making more of their production remote, why should they call SSL for System T?
They should call because it's scalable. So you set all these different devices up and you can ship the processing and some IO from that kind of remote production scenario. Or again, the same model works and it's the same software interface where you take apart the control system home and run that on a PC and kind of control it that way. I think one of the key differentiators and the important part of this is that each of those control positions are independent. So you can have multiple people working collaboratively at the same time. And that kind of helps because you can have like someone mixing a band segment while someone else does the voice. And that's always been the case with System T, but here you can do that over a big distance. So you've got multiple people working on the same console, but you're not necessarily moving the faders and having them move in both locations. You're each looking at different DSP on the same processing engine and on the same console.
Interesting. It's great how this has all moved forward. So thanks, Tom, for joining us today. hopefully
Thanks, guys.
that isn't another nail in the coffin for the broadcast OB truck.
Not quite yet.
I think not. Not quite yet. Not quite yet. I think let's call it enhancing the production. So thank you very much for joining us today, and let's hope to see you soon at the show. Thanks to Mediaproxy for their support for KitPlus TV, and you can check out more about them at mediaproxy.com. See you next time.